Hi, Algebra 1. We're looking at our Saxon Algebra 1 today, and we're starting with lesson 22. So I hope you'll join me with your textbook and open up to page 95. So this week we've already covered lessons 20 and 21. So we're looking at lessons 22 and 23 also. So we just looked over our exponent rules and how we multiply, when we are multiplying and the bases are the same, remember that our exponents are kind of like that long lost friend that's one step behind. So if the bases are the same and I'm multiplying, then I would add the exponents. So let's take a look before I jump into lesson 22 and let's review. Let's do page 94 and let's take a look at number 10. So on page 94, number 10, it says k and then y squared, k cubed, k squared, y to the fifth. So notice that there is no addition sign in between or subtraction because this is all one term. So since it's all one term, I'm just going to combine together the same bases. So all of these are k's that I've underlined. So I'm going to come down and say equals k. Now I'm going to take a look. This is no exponent, so it's an understood 1. So it'd be 1 plus 3 plus 2. Everybody see where I got that? I got k, k, and k. So I'm going to mark those out. Now, here's my y's, and I'm going to put a wavy line under those so I can distinguish those a little bit better. So I would have y squared plus 5 because I had 2 plus 5. I'm going to mark those out so I remember that I've combined them all. Now, since my bases are the same, and remember when I'm multiplying, my exponents are that long lost friend that's one step behind, so I'm adding. So I would have k to the 3, 4, 5, 6. K to the 6th, y to the 7th. And that's my combined final answer because my bases were the same and I'm multiplying. So with exponents, it's one step before and I'm simply adding them. Now, let's take a look at lesson 22. So that was reviewing lesson 21. So lesson 22, I'm looking at following my rules for expressions, combining like terms. So your book is going over those things there on page 95. On page 96, I'm looking at making equivalent equations. So that's always important. If I distribute a 2 to one part of the equation, I have to distribute that 2 to all. And that's very important as we go into further things in algebra, that you understand how to make those equivalent statements, right? All right. Your book also talks about inequalities, greater than and less than. And I know when I taught younger grades math, we would talk a lot about alligators, that an alligator eats the bigger, but you need to make sure you understand greater than and less than so you're able to say it properly. So like if I had x is greater than 4, because the alligator is eating the first, we say greater. This would be x is less than -2. So it's eating the second, so x is less than -2. So when I put that on a number line, it would be anything below a -2, correct? So that's on the bottom of page 95 as well. So you can have equations. Equations have an equal sign, or an inequality has an inequality symbol. Greater than, less than, or you can also put an or equal to at the bottom. So that would be greater than or equal to, less than or equal to. So that's very important that you understand those terminology. Your book on page 96 also has a lot of bold-faced. You need to understand those terms like a conditional equation, a solution, obviously an answer, and then it talks about root, and then a solution is another way to say an answer, and it would have to satisfy the equation. It has to be true. So anytime you get a solution, you have to plug it back into the problem and make sure, does it satisfy it? Is it true? Sometimes in algebra, there's actually times where you might plug it back in and it's not true. So that's why it's very important to always check your answers, right? All right, let's look at page 97. Does -2 or 2 satisfy the equation? So that's some of the terms your book just talked about. Is it true? Is that a legitimate solution? So let's look at practice A. So let's look at the equation. It says x minus 2 equals 0. So it says, does -2 satisfy it? So let's plug it in. -2 minus 2. Does that equal 0? Well, if I owe $2 and I owe $2 more, I would owe $4. Does -4 equal 0? So if I have no money, I actually owe someone $4? No. So I'm actually going to mark through that because that means no, it does not satisfy. Well, actually, this one was the original statement, but neither of these, when I plugged in the -2, did not satisfy it, right? So now let's look at the next one. So it says, does -2 satisfy or does 2? So let's see. So if I take this equation, x minus 2 equals 0, and I plug in 2. Does 2 minus 2 equal 0? It does. So yes, 2 satisfies. So x equals 2. But not -2 because it did not satisfy the solution, right? It did not satisfy the equation, so it was not a solution. Now, look at B. Is -2 or -5 a root of the equation? So we use roots when we're talking about anything to the second power, right? To the second degree. So let's take a look at my equation. Let me erase this. So this was letter A. Now we're looking at letter B, and it's wanting to know, is it a root? That's just another way to say, is it a solution? Is it an answer? So let's write our equation. X squared, remember an equation has an equal sign, equals -10. So the first question they ask us is -2. So let's plug that in. -2 squared plus 7 times -2. Does it equal -10? Well, let's fill it in together. So -2 squared would be -2 times -2 would be +4, canceled out. And then -2 times 7 is -14 equals -10. Is that true? Yes, I had 4, I took away 14. So when I subtracted the two numbers, I end up with -10 equals -10. So yes, -2 satisfies the solution. So it is a legitimate root. And remember, we use the term root because it is x squared, right? Now let's look at the next one, -5. Is that a solution? Is that a root? So let's do it again. -5 squared plus 7 times -5 equals -10. I'm going to draw a line here so we don't get confused. So -5 squared would be 25 minus 35 equals -10. So if I have 25, but I owe 35, that would leave me with -10 equals -10. Is that true? Yes. So both of these are roots. Both of these are valid solutions. So that was letter B. All right, so that's what you're covering in Algebra 1, Lesson 22. Now, Lesson 23 is all about equivalent equations, making sure I distribute to all so that it's fair, right? So we talked in class about if I have a pie and I have half of that pie, and I come to class and say, friends, I can only share half of my pie. So does that mean I can only give one piece? No, I just need to cut it into more pieces, right? So now what do I have? Now I didn't make more pie, right? I only have half a pie, but by cutting it, I now have 2/4, which is the same value. I just made it equivalent, right? Now I can cut it in some more pieces, right? Now what do I have? I hope you caught it. I have 4/8. Now I've had students before say, you have 4/4. That's not true because 4/4 reduces to 1 whole. I only brought half a pie to class. I can't just say let there be pi, right? I only have what I brought, what I didn't eat before, right? So 1/2 equals 2/4 equals 4/8. Do you see that each time I multiplied the same to the numerator and denominator to get those equivalents, right? I was just cutting the pieces, but I still have the same value. It just cut into smaller pieces to share, right? We all love sharing. All right, now it talks about the additive property. If A plus C equals B plus C, then C plus A equals C plus B. So we know that addition, we can say 1 plus 2 equals 3, and then 3 plus 2 plus 1 equals the same thing, right? So we can change around the order. We call that the commutative property. So that the additive property also shows that, doesn't it? All right, let's take a look at page 101, and it's telling us to solve these equations. So there are 4 of them, and we're actually in lesson 23. So let's do our practice problems together on the board. All right, so Algebra 1, lesson 23, and we're on page 101, and it says x plus 5 equals 17. Well, in algebra, anytime I'm trying to solve for my variable, my unknown, I undo the order of operations to get my variable by itself. So since it's plus 5, I'm going to minus 5. And I think of my equal signs as like a teeter-totter. In order to always keep it balanced, I have to do the same to both sides. Math is always fair, and I don't ever want to leave someone out. So I'm going to subtract 5 to both sides. By doing that, I undo the 5. I had 5. I'm taking the 5 away. Now I'm left with x, so I bring it down. X equals 17 minus 5 because I fairly took away 5 from both sides. I kept it equivalent, so I know x is 12. Now let's verify that. Let's see if it satisfies the solution. 12 plus 5 is 17. I'm going to put a check there because I verified it and I know it satisfies it. It is a solution. Now let's look at letter B. Letter B says k minus 27 equals negative 38. Now, my variable is k, and I need to get k by itself. It's being subtracted from k. So to get k by itself, the inverse of subtraction is addition. So I'm going to add 27 to both sides. So I end up with k equals, now I owe 38, but I have 27, so I'm going to subtract them. And I end up with 11, but I have more negative than positive, so my sign goes to the negative. So my answer is k equals negative 11. Now we can verify it by plugging it back in. Negative 11 minus 27 is deeper and deeper in the negatives, is negative 38. Check. It satisfies the solution. It is legitimate. Now let's take a look at C. C says x minus 1/2 equals 3/8. So if I'm getting my variable by itself, I do the inverse. I add 1/2. Add 1/2. So x equals 3/8 plus 1/2. Now if you know your fraction equivalence, I made my previous math class memorize that. That would be 0.375 and 1/2 is 0.5. And you can annex zeros, 0.50. So it would end up being 578. So x is 0.875. And those of you guys who know what 0.875 is, it is 7/8, right? So we can easily convert back and forth with our decimal equivalents. Now some of you at home may be saying, Miss Kim, I never memorized my decimal equivalents and you just lost me there. Well, you can actually plug this into your calculator, 3/8 plus 1/2. Now, don't forget to add fractions, I have to have common denominators. So I can turn 2 into a denominator with 8 just by making an equivalent again. 2 times 4 is 8, 1 times 4 is 4. So I now have 3/8 plus 4/8 is 7/8. And remember, friends, that's exactly what I told you was the equivalent for 0.875. So either of those solutions are correct, And let's see if it satisfies it. If I say 7/8 minus a half is also 4/8, I end up with 3/8. So I'm going to put a check because I know it satisfies it. All right, there were two different ways to solve that, whether you knew your decimal equivalents or not. I hope that that was a help. Now the last one, letter D, is mixed numbers because it has a whole number and a fraction. So I encourage you to work those out. Find a common denominator because it's 7 and 6. Your common denominator is going to be 42. Or you can also plug it in your calculator. Your scientific or your graphing calculator is going to have that button where you can do a mixed number, the whole number and also the fraction. So be watching that, but also make sure that you check. And I know that a lot of times we finish it and we say, haha, I'm done. Why do I need to check? But it's extremely important. Always take the time to check. All right, I'm really proud of you guys. I'm proud that we're already on page 101. So great start to the school year. Thank you guys. Have a great week, and I'll see you next week.